Hi everyone, let's continue with what we did from the preview stuff. So we have a conjecture that the derivative of sine, so this is our guess. Don't mind me while I spell out loud to myself. See what happens when I sit in a room and you guys aren't here. We have a guess that the derivative of sine x is cosine x. And we want to see if the limit definition agrees with this. So I have it blocked out to walk us through this a little because it's kind of a funny one. So to get us started, we'll say the limit as h goes to 0. Okay, so this is our function. We first need to plug in x plus h. So we'll have the sine of x plus h minus the sine of x, and then we divide it all by h. Okay, so now we need a trig identity, this one right here. It's the sum formula for sine. I don't care if you don't remember exactly what it is, but I hope you remember that it's there. The sine of a plus b is the same as sine a cosine b plus cosine a sine b. And we want to use this identity on what we have up above. So basically, we're going to use it to help us split up the sine of x plus h. So according to my identity, that will become sine x cosine h. So x is my a, h is my b. And then plus cosine x sine h. And then I still have that minus sine x hanging out, all over h. Okay, so I'm getting somewhere. What I'm going to do next is get rather clever, and this is another one. I want you to see where this comes from with the limit definition, but I won't ask you to reproduce this, so just bear with me for a couple more minutes. I'm going to group together the terms with the sine x's in them. So I'm going to say, all right, well, I could just rearrange a little bit and make this sine x cosine h minus sine x. And I'm even going to split it up into two fractions to really separate this off. So here's the one with the sine x's. These two went in the first fraction. And then we have a plus cosine x sine h over h. Okay. And then I'm even going to go one more step, I think, before I move on to the next part. I'm going to factor out the sine x. So I'm really trying to separate x's and h's as much as possible. So when I factor it out from the top here, it can just sit out to the side because it would be like it was over 1. And it leaves me with a cosine h minus 1 over h. And then in the second one, there's not really a lot to do, but I'll kind of make it look similar. I'll move that cosine x out of the fraction. Okay, so now we are supposed to look at what we've got and realize that when h goes to 0, it doesn't do anything to this sine x or this cosine x. So we could really think about this as I need to find the limit as h approaches 0 of cosine h minus 1 over h and multiply that by sine x. And then I need to find the limit as h approaches 0 of sine h over h and multiply that one by a cosine x. And lucky for us, on the first page, we did this. We figured out that cosine h minus 1 over h is 0, so this whole thing goes to 0, and sine h over h goes to 1. Which means that what I really have is sine x times 0 plus cosine x times 1, which is just cosine x. So this is our next shortcut. I don't remember what number we got to, but the derivative of sine x is cosine x. And I'm going to give you cosine for free. It's fairly similar. I guess I could have written this in a better spot. So I'm also going to give you that the derivative of cosine x is, in fact, the opposite of sine x. So it almost works out that they're derivatives of each other, but not quite. There's that minus sign that crops up. All right, thanks for watching.